for quickly prototyping. And the new input system is extremely capable with tons of features, but it's also a bit more complex. So what I do is while I'm doing a simple demo or testing out a new prototype, I just use the legacy input manager, but when making a more complex project, like for example my Steam game, then at a certain point I refactor my code to use the new input system. So here I'm going to teach you both, as well as teaching you how to refactor code, which is an extremely useful skill. So let's first begin by using the simple legacy input manager. We want some basic WASD movement to move our character, and we're going to need to run that logic on every single frame, so let's do it on update. And let's actually get rid of the code that Unity writes by default. Let's start completely from scratch, so let's get rid of this, just close, okay. So here, let's start by writing private void update. And now here, very important, if you're a beginner, make sure that update is written exactly like this. If you write update with lowercase, if you do this, then it won't work. The function will not be called automatically. I'm pointing this out because I have seen a bunch of comments from beginners wondering why their code doesn't work, and it's as simple as this. With lowercase, Unity will not call this automatically. It needs to be exactly perfect. So again, if you're a beginner, make sure you write the code exactly. The code is case sensitive, so this is very important. Also, another note, you saw that the code that Unity wrote by default when we made a new script, it just had void update. It did not have the private keyword. Private is what is called an accessor. You have private, then you have public, and then there are some more advanced ones. Technically, you can omit the accessor, and in most cases it will default to private. However, in writing good clean code, you should be as explicit as possible. There should be no room for misunderstandings. So while technically you could omit the private, you should always include it to make your code easy to read and easy to understand. This one is the first of many clean code rules that I will teach you during this course. Like I said, all of the code that I'm writing here is on the same level of quality that I use in my own professional games. I'm not going to teach you bad practices like so many beginner tutorials do. So always be explicit, always include the accessor. Okay, so we have our update running code on every single frame. Then to test if a key is being pressed, we just go inside input. Then over here we've got two functions. So we have getKey and getKeyDown. Both these functions return a boolean, so that's either true or false. The difference between them is that getKeyDown, this one only returns true for a single frame when the key is pressed, whereas getKey, this one stays true for as long as the key is held down. For example, for an action like jumping, you just want to know when the player presses the button, so for that one you would use getKeyDown. However, in our case, for a character controller, we want to know if the key is being held down. We don't want just one frame, but always. So for movement, let's make sure we go with getKey. That requires a key, so let's write our key code and then choose the key. Let's say we want W. And then let's just put this inside an if, just like this. Okay, so here we have code we want to run while holding down the W key. Let's do a quick test just to verify everything is working perfectly. And for testing, we can use the super useful debug.log. This one lets us print a message in the console. So let's add one log here, just say something like pressing. And then let's also do an else, and if else, let's do a debug.log and just do a dash. Okay, so here is our very basic script. Let's make sure to save it, so Control S. Then back in Unity, over here, make sure you have the script attached to the player game object. And now we can test. And now down here on the console, we can already see dashes, so I'm not pressing any key. Also, like I mentioned in the setup lecture, if you're seeing just one message, then maybe that means you have over here the collapse toggled. If you toggle it, look how it only shows one message, but then over here on the right side, it says the number of messages. Personally, I prefer to always keep it untoggled so I can see every single message. Also, over here on the right, make sure you have info messages visible. If you untoggle this, then you don't see it, so make sure this one, and actually both of them, make sure all of them are enabled. Okay, so we're seeing a whole bunch of dashes. And one more note, if over here the scroll bar stops scrolling, so right now you can see it's stuck up instead of being down there. So if that happens, one easy way to reset that is just click over here on clear, and it goes back into auto scrolling. Okay, so we have the dashes. I am not pressing any key. Now as I press, yep, there you go, there's the message. If you don't see it, make sure the game window is in focus. So select the game view and click right here on the middle to make this one the focused window. Then if you press the double key, you should see the message. And if I let go, yep, there it is, a nice dash. Okay, great, so all the basic logic is working. Back in the code here, now that the logic is working, let's get rid of the else here. And let's add tests for all of the other keys, so let's copy paste this. So we're going to need W, A, S, and D. So let's make all of these. Okay, so we have our inputs. Let's also get rid of the logs. We don't need this. All right, so we have all of our key presses. Now let's construct a vector with our inputs. And since we're just going to have two axes, the WS, that is forward and backwards, and this one is left and right, so just two axes. So because we have just 2, let's use a vector2, and let's call it the input vector. Let's construct it, so we'll do a new one and start off at 0, 0, okay. Then over here, the logic is pretty simple. So when we press W, then let's go into the input vector and set the Y to +1. Then when we have an S, we want to go backwards, so put the Y on -1. For the A, we want to go left, so that's an X on the -1. And finally for the D, that is an X on +1. Okay, so with this, we have our correct input vector. Let's do a quick log just to test. So debug.log on the input vector. Okay, so let's test. All right, so we can see in the log 0, 0. Okay, makes sense. Now if I press W, yep, we've got a 1 on the Y. If I press A, we got -1 on the X. Press D, +1. Press S, and -1. Okay, great. So everything works. Except we also need to be careful about one other thing. If I press both W and D, with this, look at that, the vector is 1, 1, which is correct. That's exactly what we did. Except the vector 1, 1 actually has a bigger magnitude than just one vector. If we leave it like this, then the character will move faster when moving diagonally versus when moving in just one direction. For our input vector, we really want it to be normalized, meaning we want it to have the same size regardless of the combination of keys that we're pressing. So back in the code here, after calculating the input vector, let's simply normalize it. So we go into the input vector and we set it equals to input vector dot normalized. So this will normalize our input vector. Let's see. Now over here, if I press W, yep, got 1, press S, -1, okay, so all of those work. Now if I press both W and D, yep, there you go, now it says 0.71. When you combine both these and you do the math, these do end up with a magnitude of 1. So with this, our character will move at the same speed on both diagonals and straights. Okay, so we have the input vector all correct. Now let's actually apply some movement. For that, there are many ways of making a character controller. For example, you can decide to use physics or not. Over here, I want to keep the game simple, so let's not use physics. Instead, let's just move the player transform directly. Over here, we have our input vector. Okay, great. Now we want to apply this to our character position. So first, we access the transform. This one refers to the transform where this script is attached to. This script was attached to the player, so this is going to refer to the player transform. Then we want to modify the position, so let's access the position. And now for moving, we don't want to just assign it. If we do something like this, the player would never leave the center of the world. It would always be near 0, 0. So instead, we don't want to just assign it, but instead we want to add onto it. Now, if you're a complete beginner and you don't know this syntax, then this one is exactly the same as this. So transform.position equals transform.position plus input vector. So both these two lines are doing the exact same thing. Personally, I prefer to use the shorthand. I find that equally readable and more compact. Okay, so we have this, and we add our input vector to the transform position, except we can also see a really nice error. Basically, it's telling us that we are mixing two types. Our input is a vector2, where we only have an x and a y, but transform.position is a vector3, meaning it has an x, y, and z. One simple solution is to cast our input vector onto a vector3, so we just convert this from one type into the other one. And yep, we don't have the error, so let's test. And now if I press W, and yep, the character does move. Let's ignore the massive speed for now. So it does move, it does seem slightly correct. Except you can obviously notice that it's not correct. We are moving on the x-axis, so left and right, that is correct, but then we are moving up and down instead of forwards and back. Basically, we converted the vector2 directly into a vector3, so we are moving on the x and y axes. But in our 3D game, we really don't want the characters to fly, so instead we want to move on the x-z axes. So back in code here, instead of directly casting this down into a vector3, let's construct a move dir vector. So let's do a vector3. Let's call it our move dir for our move direction. And over here, we construct a new vector3. And basically, we're just going to assign the input y to the z on here. So first of all, for the x, that one is correct. So input vector.x. Then for the y, let's leave this one on 0. And finally, let's use the input vector.y as a z on the move direction. Also, now at this point, you might be questioning, if we're using a vector3 here, why don't we also use a vector3 up here, and then just assign the z directly? That's certainly a possibility, and for making a super quick prototype, I might even do that myself. But the proper answer to that is once again all about writing good clean code. The input, logically, only has two axes. There's no z-axis on your keyboard, so logically it makes no sense for the input to have three axes. And beyond that, you should keep the logic separate, so you should first get the input and then actually move the object. We're going to see the benefit of that separation when we refactor this code to work with the new input system. Doing that will in turn make enabling gamepad joystick support super easy because we have the input vector separated from the actual movement. So all of that to say, let's do things properly. Let's keep the input vector separate from the movement vector. So we just translate the xy onto xz, and then we just apply this into our transform position. Okay, so let's test. So now if I press D, go right, go left, and press W and S, and there you go. Okay, great. So it is indeed moving left, right, forward, and back. Okay, great. So it is working, but as you can see, it's moving insanely fast. You might think the issue here is just applying some sort of movement speed multiplier, except there's actually one sneaky issue here. Here on the game view, on the top right corner, we've got a stats button, and over here we can see a whole bunch of things. Specifically, we can look at the frame rate. We can see that it's running at 144 frames per second. Over here on the left side, on this button, I have VSync enabled. This will cap the frame rate to the monitor's refresh rate, so that is why I'm seeing 144 Hz. I can over here disable VSync, and yep, look at that, goes all the way up to 700. Basically now the game is running as fast as my computer can run it. And if I press the movement keys, and look at that, now it's moving even faster. Now I've completely lost track of where my player is. This is not what we want. We don't want the player to move at different speeds depending on the frame rate. We want it to always move at the same speed regardless of frame rate. So when you do any kind of movement logic on an update, you always need to make sure to multiply by time.delta time. What this variable contains is the number of seconds elapsed since the last frame. For example, let's add log to this. We no longer need the input vector, so let's log just the time.delta time. Okay, so we can see there, that is basically telling us how many seconds it is taking to render a single frame. Once again, note how I have VSync enabled, so I'm running at 144 frames per second. And now if I disable it, let's see what happens to that number. So if I disable, and you have to look at that, that number is now much smaller and the game is now running much faster. So by incorporating this value into our calculation, we are going to be taking into account the frame rate, thus making sure that the movement is always frame rate independent. Right now with this frame rate, if I move, you can see I'm moving at this speed, and now if I enable VSync, change the frame rate, and I move and I'm still moving at the exact same speed. Okay, that's great. Except obviously it's not exactly great, it's moving way too slow, so let's also incorporate a movement speed. Now for this, once again, most beginner tutorials would teach you to go all the way up here and define a public float move speed. Maybe default it to some value like 7f, something like that. Then you have this field, and then down here you simply use it in the calculation. So movement here, multiplied by move speed and by time.delta time. So this is what most tutorials would teach you. By making it public up here, what you're doing is you're enabling access from the editor. So if you go over here in the editor, over there on the player, we can see the move speed variable. We can see this exposed and we can modify it. This makes it really easy for testing and for iterating upon the value even while the game is running. So the game is playing, I can move and I have this move speed. Now I can modify this, and yep, now I got a different move speed, so I can use this to quickly iterate and find the perfect value. So it's great to have this variable exposed in the editor. And this feature is indeed the reason why most beginner tutorials would teach you to make it public. It's so you can see it in the editor. That is indeed a very valuable thing. Being able to easily iterate upon important values is always very useful. However, when you make something public, when you do that, you don't just expose the field to the editor, you are exposing it to every other class in your entire codebase. So some other class could access this field and set the player's movement speed to something like 0, and you would have no idea that was happening because the issue would not be on this code right here. I have an entire video on this subject, why you should not make everything public. This is an extremely important topic to know about. This one tiny change will massively improve the quality of your code. Definitely go ahead and watch that video to learn why it's such a bad thing and make sure you don't do it. So to avoid all kinds of problems, you should never make fields public. So very quickly, the obvious alternative is make it private. Making it private means that only this class, only the code in here, only this can modify this field. So you know for certain that no other class can ever modify this. However, making it private also means the editor cannot modify this field. So we've lost our very useful iteration approach. So what we can do to expose it just to the editor is to keep it private, and then we add the attribute serialize field. This way this field is still private, meaning that it can only be modified by the code inside the player class. But with this attribute, over here in the editor, yep, we do have an editable field. So only the code in that class in the editor can modify it. Nothing else can touch it, nothing else can read or write, which is exactly what we want. One of the main rules in writing good clean code is minimizing complexity, and one of the easier ways to minimize complexity is simply to minimize access. By making this field private, we are minimizing complexity because it doesn't matter how complex our game is. Maybe our code base is 1,000 classes long. It doesn't really matter because only this class can ever touch this field. So if we have a bug related to the movement speed, we know for certain it has to be inside this code and nothing else. So we minimize the things we need to keep in our head, which is always a very good thing. Okay, so with all that said, we have our movement speed, and down here we are incorporating it into our calculation. Just with this, we have our character working with a variable movement speed, and by using delta time, we have our movement correctly being frame rate independent. So here's our character, and using the keys I can walk around and yep, the character moves in any direction. So we have movement fully working while using the legacy input manager. Like I said, we're going to learn how to refactor our code to use the new input system. Learning how to refactor is an extremely important skill to improve your own programming skills. It is something that you should always do when necessary. It will massively help you improve the quality of your code. So we're going to do that, but before we get to that, let's actually do something a bit more fun and add some proper visuals and animations to our player in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to replace our boarding capsule visual with a nice proper character mesh. Okay, so in the included assets project files, over here, if we go inside the prefab visuals, we see a nice player visual. Let's position it inside the player game object, so let's drag it inside. Again, because we separate the logic and the visuals, this is going to be pretty easy. We don't need to modify the parent game object at all. We just drop the visual as a child, that's it. Also, again, very important, make sure the visual is over here on local position 000. Only the parent game object should move, the visual itself should never move. If you notice some weird positions as your player moves and rotates, always check to make sure that the child visual is on 000. Okay, so with this, let's delete the old capsule. Delete it, okay. So here we have a pretty simple but really nice character visual. It's really just two spheres stacked on top of one another with a bunch of eyes. Very simple. For the visual itself, the material is using just a solid color. So here it is inside the assets material. You can see a bunch of player bodies with different colors. These different colors, they won't be used in the upcoming multiplayer video. Basically, each player will have a different color. Also, by the way, if you're a complete beginner, here's a quick lecture on materials. These are materials, and if we click select, we can see a bunch of stats related to that material. Basically, the materials have a shader and then a bunch of properties. Now, the shader is the actual code that runs on the graphics card that says how an object should be rendered. By default, you have a whole bunch of included shaders. We're using the universal render pipeline, so you should mostly be using the ones inside the URP. And by default, you probably want to be using the standard lit shader. Then, of course, you can also build your own custom shaders. One excellent tool for doing that is Shader Graph, which I have covered in detail in a previous video. It's a fully visual tool that you can use to make shaders without having to write any shader code. It's a great tool. I've also made a bunch of tutorials on all kinds of effects you can make, although right now we're not going to be using custom shaders. We're going to do that later on in the course, but for now we're going to stick with the default lit shader. So materials have a combination of shaders and the properties on that shader. For example, over here for the default lit shader, you can see that it has over here a base map, that it has a color field. This is what you can change to apply a different color to your player. Also, as to how you apply a material to an object. Over here on the player visual, you can see the objects are made up of a sphere. So this is the mesh and then the mesh render. This is the one that has the material. So both these are what stores the shape as well as the visual for the object. The mesh is just a 3D shape, but just by itself, the mesh filter doesn't actually render anything. So it needs the mesh render, which needs a material attached to it. So for example, over here on the hierarchy, let's right click on empty space and let's create a brand new cube just to see it. So yep, there you go. It does create an object. And as you can see, it has a mesh filter and a mesh render. Now to apply a different material, you can click on this little circle icon and it shows you all of the materials in that project. Alternatively, you can grab the material directly from the project window. So for example, the player body, just grab it and drop it in there. Or you can also drop the material over here on scene view. As you can see, as I mouse over different objects, it applies that material to a different object. Although note, that only works over here on scene view, it does not work on game view. So this basically sets the material over there on the object. Now, one more very important thing on materials. If you have multiple meshes only using the exact same material, and then you modify the material, it will change the visual on all meshes using that material. So for example, if I modify the color here, put it on something different, there you go, all three instances, all three objects that are all using the exact same material, they all update with a new color. If for example, you wanted the head to be a different color from the rest, then you would just create a new material. So you can right click on the project window, let's create a new material, then you can give it a name, give it colors, use a different shade or whatever, and then use this one for something different. So that's pretty much the basics for materials. And by the way, if you're a complete beginner and you have questions, remember to post them in the comments and I'll do my best to help. Like I said, I want to keep this video moving. I'm trying to teach as much as possible while still keeping the video a reasonable length. So if you need any further clarification on anything specific, just go ahead and ask in the comments. Okay, so when the materials are out of the way, here we have our player with visual. Let's just get rid of our cube, okay? And just with this, if we test, and yep, over here we already have a nice player visual walking around. Okay, great. Except the player isn't actually rotating. Ideally, the visual should be facing the walking direction. So if I walk down, it should be rotated to face down. So let's add that. Doing that is actually going to be pretty simple. Let's go into our script. Here we are on the player script. And over here, we already have the movement direction. So we're going to use this in order to make sure to rotate the game object to face this move direction. And for rotating a transform, there are many ways to do it. One obvious one is to modify the transform.rotation. However, this one, as you can see, works with quaternions. For me, even though I've been doing game dev for over 10 years, I still find quaternions quite a bit confusing, so I normally don't use this method. Another method is to modify the transform.Euler angles. This one is much more intuitive and makes more sense to me. It works with regular Euler angles, which is much easier to understand. If you don't know that name, it really just means the angles that go from 0 to 360. Then for another method, you can also use the function transform.lookAt. This one makes the transform look at a certain point, so it can be a transform target, can be a vector3 for one position, anything like that. So this is a very useful function. We could calculate a point right in front of our move direction and look at it. Or finally, the method that I personally like to use for this specific purpose, which is just modify the transform.forward. This one has the normalized vector representing the forward axis, and importantly, you can get it and you can also set it, so you have both read and write. You can read it to get the current transform forward, but you can also write to it to essentially rotate the transform. So we can just assign this to our forward vector. Also, by the way, you also have transform.up and transform.right. Both these work exactly the same way. For example, transform.right, this one is extremely useful for 2D games, but over here we're working in 3D, so we want transform.forward, and all we need is the forward vector, which is really just the move direction. So let's set this one equals the move there. Okay, so just like this, it should already work. Let's also just clean up the log. We no longer need to see the delta time. Okay, so let's see like this. Okay, here we are, and as I move, and yep, there you go, and look at that, the player object does indeed rotate to face the move direction. Okay, so it's already looking great. All right, awesome. However, it also looks a bit odd with how it's instant. So I move left and right, look at that, it instantly rotates. So there's no smoothing, nothing, it's way too janky. So let's add some nice simple smoothing. And for that, let's use a really awesome, really useful math function called lerp. It helps you interpolate between two values. I made a quick video showcasing a bunch of uses for it. You can lerp floats, vector3s, quaternions, or just about anything. It's really perfect for making some smooth movement or smooth rotation. So for that, we can access the function inside the vector3 class, so we can find lerp. Then here we actually have two options. We've got lerp. This one interpolates, and we've got slurp. This one interpolates, but with a spherical interpolation. Basically, if you're dealing with rotations, like what we have here, then we want to be using slurp. Whereas if you're dealing with just positions, then you want to use lerp. So here, let's use slurp. This one, as you can see, takes an A, a B, and a T. Like I said, this interpolates between A and B based on T. So for example, if T is 0, then it will return the value A. If T is 1, then it will return the value B. If T is 0.5, then it will return the point in between A and B. If you want to learn some more about interpolation and the math behind this, then I highly recommend you look at my video on splines. Splines are basically just a whole bunch of lerps put together. So anyways, over here we can add some smoothing to our rotation by just using the current transform.forward as our A. Then for the B, this one is our target, so let's use the move there. And finally for T, let's use time.delta-time. Meaning that with this, over time the character will rotate towards our target movement direction. So just with this, let's test. So here if I move to the right, and yep, look at that, it is indeed rotating. It's way too slow, but yep, it is rotating smoothly. Alright, so let's just add a bit more speed. So over here, let's just find a float for the rotate speed. Let's put it at something like 10f. Then we just multiply it, so time.delta-time multiplied by our speed. Let's see. And move, and yep, there you go, look at that, much better. Okay, great. So as you can see, everything works. As I move, the character does rotate to face the move direction. Alright, great. So here we have our character with a nice visual, all rotating to face the move direction. Now the next step is we want to add some nice animations, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add some animations to our player character. Now, I have already included some pre-made animations with a pre-made animator over here inside the assets folder, but let's first do it from scratch just so you'll learn how to do it. First, to animate, we're going to need the animator component. If we go inside the player visual game object, once again, remember all the visuals go on the visual game object. So for adding the animator component, we want it on the visual and not on the logic component. So anyways, over here, as you can see, by default, I already attached it with the assets included, but let's do it from scratch. So let's remove this by default. Now let's add a new component. Let's call it an animator. Also, one very important thing here, it's the animator component, not the animation component. These two are completely different. The animation component, this one is actually related to Unity's legacy animation system from a very long time ago. It's only here pretty much for backwards compatibility and for super simple use cases. So most of the time, make sure you're using the animator component. Okay, so to drive this animator component, we need an animator controller. Let's go into our project files and let's create a brand new animator controller. Let's call this my player animator. Then let's select the player visual and just drag the controller on there. Okay. Again, if you have issues and you cannot drag the animator onto the field, make sure you're using the animator and not the animation component. Okay, so with this, we have assigned our animator controller. And now let's double click on it to open the animator window. And if you don't see it, then go into window, then go into animation and open up the animator window. And also, if you still don't see anything, then maybe you might have some issues with your layout. If that's the case, then go onto the top right corner layout and go back into the default and then back into your own layout. And finally, if you still don't see anything on this window, if you don't see the default states, make sure you have the object selected in the hierarchy. So with that, you should be able to see these states. So this is our animator controller. Now I have a really detailed overview of the animator and the animation windows in my Ultimate Unity overview course. So you can go watch those lectures for some really in-depth explanations about everything this does. Basically, the animator is a state machine. So you have various states and you can create transitions between each state. By default, you have these three special states. There's the entry state, exit, and any state. These are used for making transitions, but we don't really need to worry about them just for now. First, let's just make a basic new animation. And for that, the easy way to do it is to open up the animation window. So let's go up top into window, go into animation and open up the animation window. So here it is. Again, that's a different window. That's animation, not animator. And for me, for this window, I like to dock it down here. So there's a nice timeline. So I think this is good. Okay. And now if we select the object in the hierarchy that has our animator, then we can see the text here. So to begin animating, we've got a nice button to create an animation. So let's go ahead and click on this. And now let's give it a name. For now, let's first make the idle animation. So let's just call this idle. And yep, just like that, we have created an animation. You can see the animation window down here has changed. We now see a nice timeline showing the time. And also on the animator controller, you can see the new animation was added as a brand new state. So a new state was created, and if you click to select it, on the right side in the inspector, you see the motion, so the actual animation selected. And you can also see that there's an arrow pointing from the entry onto the idle state. So that means this one is going to be the default state. When the animator controller starts, it will start playing right on this state. Let me just point out one more thing related to animations. So on the project window, we can see, yep, here is our animation that we just created. And you can see the inspector looks just like this. Now, if your inspector looks differently, that might be because you accidentally created a legacy animation. That has to do with the previous animation system that I talked about, the one that is legacy that should really no longer be used. So if you see a different inspector, then a quick way to fix it is to click on these three dots on the inspector, these three dots. Then you change the inspector into debug inspector. And over here, you see a toggle for legacy. So for the animations that we want to use right now, we do not want to be using legacy animations, so make sure this one is untoggled. If in your case it's toggled, just untoggle it, then go back into the normal inspector, and now, yep, it should look just like this. Okay, so we have our animation, and now it's on our animator controller. Now let's actually make an animation. So let's select the animation window, and again, let's make sure to select the object, so let's select the player visual game object. So here on the animation window, we see this nice little red button. This one enables or disables recording. So if you click on it, you can see, yep, the timeline is now red, meaning that we are now recording. And now we can do anything to any child objects and it will record any changes we make. Now note what I said, that's very important. It needs to be child objects. If you select, for example, the parent game object, then all of a sudden it stops recording. So you can only animate child objects. So let's select the player visual, let's enable recording, then let's expand the player visual. Let's make sure that our timeline is on 0, so drag it all the way to the left. And now for example, let's grab the head object and let's move it just a tiny bit. Basically just move it enough in order to make sure that the position over here is in red, meaning that we have recorded a keyframe. Then let's drag the timeline by a little bit. Let's go over here to frame 30. This one is actually going to be half a second, and it's going to be that because over here on the samples, this is the frame rate for the animation. So at 60, that means we have 60 frames. This makes 1 second, so 30 frames would be half a second. You can also zoom out by scrolling over here or dragging the handles down here. So let's go into 30, half a second. And on this one, let's move the head by a little bit, something like this. As you can see down there, we can note that it recorded the new keyframe. And now if we hit on the play button, we can preview the animation, and yep, look at that, it does do exactly that. So it starts off down and then moves up. Okay, so that's great, but we don't want it to snap back, so let's actually add another keyframe right at the end. So let's stop playing the animation. And to make sure we have a perfect loop, let's just click to select the keyframe. Let's press Ctrl C. Then let's go down into the 1 second mark. let's press Ctrl V, and there we go, there's the exact same keyframe. So now if we hit on play, yep, there we go, we have our nice seamless loop. So the head goes up and down and repeats forever. All right, awesome. Okay, so that's great. Now let's also do one thing. Let's also record a keyframe on the body. However, we don't want it to move, at least not in this idle animation. We just want to have a static keyframe. So let's select the body, and let me actually move it a bit to the side just to make sure to record. And now manually, we can modify the things over here to modify the actual keyframe data. So on this one, I don't want it to move, so let's put it all the way back at 0, just to make sure we have a nice keyframe recording. Now, the reason why we are recording the body position even without moving it is because the wonk animation will indeed move the body, but when we get back to idle, we want the body to go back to this exact position. So that is why we need a keyframe here. Okay, so that's done, so we can stop recording. So let's click on the red button again. Okay, great. By the way, one more note to make sure that the animation loops, go into the project window, and over here select the animation and make sure loop time is enabled. It should be there by default. Okay, so the animation is set up, and if we look in the animator, it's already the default state. So if we hit play, we should be able to see the idle animation playing nonstop. So let's hit play, and yep, there it is, the idle animation with the head moving up and down. Everything works perfectly. All right, awesome. Okay, so next up, let's make a wonk animation. Now for me, when making an animation that is based on another one, I like to actually duplicate it instead of starting from scratch. So over here on the project window, let's select the idle animation, and let's duplicate it, so Ctrl D. Let's rename this one to the wonk animation. And now if we select the player visual and then we go into the animation window, over here we see a nice little drop down menu for all of the animations, except right now we don't see the wonk animation, we only see the idle animation. That is because this menu only shows animations that are attached to the animator. So first we need to add the animation onto the animator component, and how we do that is actually super simple. Let's just open up the project window and just drag the wonk animation and drop it here. That's it. So with this we have attached a new state to the animator controller, and now if once again we select the object in the hierarchy, go into the animation, click the drop down menu, and yep, now we do see the wonk animation. So let's click to select this one, and now for this one, let's make the animation. So let's look in scene view and make it bounce just up and down. So I'm going to enable record, go back here, and for the body, this one already has a keyframe. So let's go up here, move it a little bit, and then copy the keyframe, put it the same one at the end, something like this. So there you go, just goes up and down. Let's actually put it offset so it looks a bit better. So something like this. By the way, in a bit, we're going to replace these animations with the ones that I made previously. So don't worry about making the animations perfect unless you want to do that. Okay, so there you go, that's the animation. Although for walking, it should be much faster. So here's a quick animated tip. The stop bar here lets you select all of the keyframes within a certain time. So if I click to select, note how it selects both those keyframes. And also if you click and drag whilst on top of here, you can select multiple keyframes. So for example, to select everything, just click and drag to select all of them. And now you see these nice little vertical bars. So if you click on those and then you drag them, you can basically modify the time of all the animations and everything matches up. So for example, let's make this one super fast. Let's put it just 20 frames. So there you go. Now it's a much faster wonk animation. Okay, great. Let's click on the right to stop recording. All right, and back in the animator. So over here we have both animations. And now what we need is to make a transition going from idle into wonk. Otherwise, the wonk animation will never play. So how we make a transition is also super simple. Let's right click on the idle state. Let's make a transition. Then now we have a nice little arrow under the mouse. And now if we go into the wonk and click on it, there you go, we have a nice transition. Now we can click on the transition itself to select it. And over here in the inspector, we see a bunch of transition options. So let's expand the settings. Yep, there you go, everything. Now, like I said, I covered all of these options in a lot of detail in my Ultimate Unity Overview course. So if you want to learn more, go watch that. Here, let's just learn the basics for how to achieve our goal in making a simple player animator. The important one is over here, the exit time. Basically, if this one is toggled, then this transition will be triggered automatically, meaning it won't play the idle animation and immediately transition into the wonk animation. So for example, if we hit play and look at it quickly, yep, there you go, there's the idle, and yep, transitions into wonk. And now it stays there forever. Okay, so that's good, but not exactly what we want. We want the wonk animation to only play when the character is wonking, and when it stops, we want it to go back into the idle animation. Now for that, we need to use animator parameters. So back in our animator, on the top left corner, we see something called layers. We don't need to worry about that for now. And then next to it, we see parameters. Then we can click on the plus button in order to create a brand new parameter, and you can see all of the various types that we can create. Now for wonking, we want something that we can set to either true or false. So let's go with a nice boolean. And for name, let's call it is wonky. Again, pay very close attention to the capitalization. This is extremely important. Just like code, is wonking is different from is wonking. So make sure the capitalization is perfect. Okay, so with that, we have our nice parameter. Now let's click on transition going from idle into wonk. And now let's untick exit time. We don't want this transition to trigger automatically. And as soon as we do, we see this nice little warning. Basically, it's telling us that this transition will never happen. So over here, we have the nice conditions. If we click on the plus icon, we can add some conditions. And for for this one, we want this transition to happen from idling to walk when the parameter is walking is set to true. So that's it. This is our transition. Now let's just do the reverse. So let's right click on the walk, make transition, go back into idle. Let's click the select transition, get rid of the exit time and conditions when is walking is set to false. Okay, so just like this, our basic animation logic should be working. So let's test. So here we are, and the character is playing the idle animation. By the way, you can look at the animator while the game is running. So let me just drag the animator window, just drag it and put it on the side of the game view so we can see both at the same time. Okay, great. And right now, note how it's not updating. So there's nothing moving over here on the animator component. That is because, like I said, you must select the object. So on the hierarchy, make sure you select the player visual, and yep, there you go. Now you do see that updating. So make sure the object is selected in the hierarchy. And over here, we see a nice little progress bar showing the idle animation constantly playing and looping. Okay, great. Another important thing is over here the parameters. You can manually change the state of these while the game is running. So for example, if I click, it's going to trigger the isWalking parameter, which should trigger this transition and should go into walk. So if I click, and if there you go, transitions into the walk animation, and now, yep, it is playing the walking animation. And if I click to untick it, look at over there what happens, untick, and there you go, transitions back into idle. All right, awesome. So as you can see, we have all of our logic working. We have the animator with both of our states, and by changing this parameter, we can change which animation is playing. Now, of course, the goal is not to trigger this manually by clicking on it, but rather doing it through code. But at least for now, we know that our animator is fully set up. Again, if you want more detail on the animator and animation windows and everything related to animations, then check out those lectures in my Ultimate TNT overview course. And also later on, for more advanced use cases, I have a video on the animation rigging package. This one is for more advanced use cases for making dynamic procedural animations. It's really fun, so definitely check it out, but only after finishing this course. That one is a much more advanced tool. For now, let's continue here. So we want to trigger our parameter, but do it through code. And again, here we have yet another clean code question. Technically, we could add that code directly over here on the player script. We could just grab the animated component and change the parameter. And in this case, for this very simple game, that would actually not necessarily be a very bad approach, since the game is so simple with so few animations. But like I said, I want to teach you proper good practices, so let's make it properly and actually separate the animations from the logic. For that, let's go into our project, right click in our scripts folder, create a new C# script. Let's call it the player animator. Let's select the player visual game object and attach the component. Okay, so now here, first let's grab the animator. Now one approach is, like we've seen, we could just make a serialized field and drag the reference in the editor. That's one approach. Or alternatively, since the animator is attached to the same game object as this script, then we can just do a get component. Both approaches are really valid. So here let's use get component just to see a different approach. So we just have a field for our animator, so animator. And then we just do a private void awake. And then awake, let's do get component of type animator. And we set our animator variable. Again, like I mentioned, very important, make sure you don't mix animator and animation. These are two different components. We want the animator. Okay, so with this, we have a reference to our animator component. And now how we modify the parameter is actually very simple. We just access the animator, and then we have a bunch of set functions. You can see we have one for each type. So we've got a set bool, set float, then down here a set trigger, set vector. So function to set any parameter type. Now we made it a boolean, so let's use the set bool. And this one, as you can see, takes the name for the animator parameter. By the way, strings are a horrible way of identifying things, but sadly this system really does require strings to identify the parameter we want to change. If you're wondering why strings are bad for identifying things, the reason is because it's very easy to make a mistake. For example, if you use is walking here, then this will work. However, if you instead write is walking, then all of a sudden it does not work. If you write is walking like this, doesn't work, like this, doesn't work. And even though it doesn't work, it will also not throw any compiler errors. That is because for the compiler, a string is a string, it's always valid. But then when the code runs, this one is going to be different than our parameter, which is named example like this. Always remember that strings are case sensitive. So that's one reason why you should never use strings to identify things. It's very easy to make tons of mistakes that are then very difficult to find out. But like I said, in this animator system, we have to use strings. There's no other way. In order to minimize our usage of strings, one thing we can do is, for example, let's define a constant up here. So let's make a private, make it const for a constant, meaning this will never change. Make it of type string and call it is walking. Again, refer back into the naming rule section. For constants, we always use uppercase, snake case. So is walking, and let's set it with is walking. Again, make sure you don't make a mistake here. Make sure you type it exactly like you did on the animator. Then down here, let's use is walking. And now if we do make a mistake, so if we accidentally use something different, now we do get a compiler error, so at least we have a little bit of protection. Okay, so this one takes a string for the name and then a simple boolean for the value. So this is going to be the value that we want to set to our parameter. Now for this one, we want to set to true when the player is walking and false when it's not. So for that, we need to ask the player what it's doing. So let's go over here into our player class. And let's make a function to return just that. So let's make it public because we're going to access it from another script. We're going to return a bool and call it is walking. Now over here, we just need to return if the player is walking. So let's make a local field to store that state. So over here, private bool is walking. Again, note the capitalization. For fields, we start with camel case, whereas for functions, we have Pascal case. So these are different, okay? So basically, in order to define if we are walking, that's very simple. It's just down here, we have the movement direction. So we are walking if the move direction is different from vector 3.0. Which, by the way, vector 3.0 is just a shorthand for writing 0, 0, 0. So if the movement direction is different from 0, then we are indeed walking. So we define that, we update that field on every update, and then over here we just return it, okay, just like this. And now back in our player animated component, over here first we need a reference to the player. So let's add it here. Let's add a serialized field of type player. And we need to compile this in order to drag the reference. So let's just comment out this line just to make sure the code compiles. Now here with the code compile, let's drag the reference of our player. Okay, that's it. And then over here for the animator, set is walking. Let's go into the player and let's ask is walking. And of course, we don't want to do this just on awake. We want to do it on every single frame. So let's do a private void update. And on update, let's do this. All right, that's it. So this should be working. Let's test. So here we are starting off as idle. And now as I move, yep, there you go. It is playing the walking animation. And now if I stop, and yep, there you go, back into idle. All right, awesome. Everything does work perfectly. Okay, great. We can even look at the animator to see the state change. So here with both side by side and with the object selected in the hierarchy, right now you can see is walking is false, so it's on idle. And as I move, that one stays true, that one goes into walk. And now if I let go, if there you go, back into false, back into idle. All right, awesome. So with this, everything is working perfectly. If you're having issues, make sure you pay attention to the capitalization. So make sure the name you wrote here is exactly the same one that you wrote here. And it's exactly the same that you're using here. All right, so all of our animations are working perfectly. Now, if you want, you can go ahead and make your own animations, or you can use the ones that I pre-built. So in the included project files, inside the assets here, we've got the animations, and we've got the player with the idle and the walk animations. If we double click on this to look at it, you can see, yep, it looks exactly the same. So there's a parameter called is walking and our transition, so everything is exactly the same. Just over here, let's select the player visual, and on the prefab, like we saw, we already had the animated component. We just removed that one from the prefab in order to build it all from scratch. But if you want to use my animations, then we can just go ahead, remove the animator that we added, and then right-click on this one on the remove component. Let's revert back to changes. And there you go. Here we have our animator with the player controller. So that's the one in the included animations. And just like this, if we had on play, and actually over here I found an issue, although in your case there shouldn't be any issue because I have updated the assets. But this is a good time to teach you about any issues with animations. So if you select the animation and you select the animation, then over here you might see some of them in yellow saying missing. Basically the way that animations work is based on the actual name of the object. If it cannot find an object with the exact same name, then it cannot load the same animation. So my problem is that when I initially made the assets package, I made this animation and the object was previously named face, and then I renamed it to head, so now it no longer loads. So if you ever have problems with loading animations, just make sure the names perfectly match. So in my case, I can just click in here in order to rename this keyframe on the animation. And I'm just going to use the name that I renamed it. So head, and just like this, yep, the animation does play correctly. So just a nice quick tip, if you ever have problems with animations, always remember that the stored keyframes, they're all stored based on name. So if you rename the thing in here or over here on the game object, if you rename, you're going to have missing animations. But if you make sure the names match, then the animation should load perfectly. So let's hit on play. And if there you go, there's the idle animation. And if I move, yep, there's the nice walk animation. So everything still works perfectly because it's only using the exact same parameters. All right, awesome. So like I said, if you want, feel free to make your own animations or use the ones that I've included. For me, I'm going to be using these ones. So the ones that we made just for learning, which I created down here. So the my player animator and these animations, I'm just going to delete these just to keep the project clean. So just delete and just like that. Okay, so now that we have our character fully working, let's quickly handle our camera. Hello and welcome, I'm your Code Monkey. In this lecture we're going to quickly install Cinemachine. This is a Unity tool that makes handling cameras super easy. Our game isn't really going to have a moving camera, so this part isn't strictly necessary, but Cinemachine is a super useful tool, so I definitely want you to learn about it. Okay, so let's begin by installing the package. Let's go into Window, open up the Package Manager. Then up top, let's make sure we are in the Unity registry. Make sure you're on the Alt tab, and now just scroll down until you find, yep, there it is, Cinemachine. Okay, so let's go ahead and install this. Alright, it's installed, so let's close this. And now the way that CineMachine works is by creating what is called a CineMachine virtual camera. So let's go up top into the game object menu, then scroll down into CineMachine, and over here you can see that we can create a multitude of virtual camera types. Now, just by the names, you can see how this tool is insanely useful. For example, making a free look camera. Doing that from scratch is a bit tricky, but with CineMachine it is super easy. For our case, like I said, we want the absolute most basic thing possible, so let's just create an empty virtual camera. Okay, that's it. This creates a virtual camera over here in the hierarchy. In turn, this object has the CineMachine virtual camera component. And also importantly, when we added this, it also added over here on the main camera. If we scroll down, we can see it has a CineMachine brain component. Basically, the way CineMachine works is it works on top of the main camera, so it doesn't replace it, it works on top of it and drives the main camera. So now that we're using CineMachine, if we try modifying the main camera game object, so for example over here, if I try to drag the field of view, nope, does not work, I cannot move it. If I try to move the position, nope, can't do it. If I try to rotate it, nope, that does not work. Like I said, when working with CineMachine, the CineMachine brain is what drives the main camera. So rather than modifying the things over here on the camera itself, what we need to do is change them on the virtual camera. So over here we have pretty much the exact same options that we have on the main camera. For example, modifying the FOV, over here we've got the lens, so we can modify the FOV, and if we look in the game scene, as we modify this one, yep, it does modify the actual properties on the actual main camera. Now this has tons and tons of options related to everything. The most important ones are all kinds of options down here for the body and the aim. So this is where the camera is positioned and where it's looking at. Using this, you can make a follow camera in 5 seconds. It really is insanely useful. If you want to learn about CineMachine in more detail, I have a dedicated video on it. I go through what all of these options do. Then I also have another super detailed video on how to make a camera system with pan, zoom, scroll in both 2D and 3D and a bunch more features. Again, all of it using CineMachine. But in our case, we really want to keep it simple. So let's just position our virtual camera on the same settings that we had previously. So first, let's set the field of view. So for our game, we want something narrow, so let's go with just 20. Then for the position, let's put it above. So 0 on the X, then 21.5 on the Y, and minus 21.3 on the Z. Then for the rotation, 46 on the X, and then 0 on the others. Okay, so our camera is positioned in the exact same position. And if we head on play, yep, everything still works the same. The camera is looking from the same point of view, and the character still works. Everything's still exactly the same. Now, since we're using CineMachine, we can easily add some things on top of this. Like for example, we can add some noise to our CineMachine camera to make it smoothly move a little bit. This one is a fun, simple effect that can make our game feel a bit more dynamic, especially in games like this where we have a fixed overhead view. How we do that is over here on the CineMachine virtual camera, we've got a field for noise. So let's click and let's select basic multi-channel purlin. And then over here, we've got the noise profile. So we can choose one of the included ones, or we can create our own profile. So for example, let's go with handheld, normal, mild. And by the way, you can actually modify these settings while the game is playing. So here it is, the game playing, and you can see what this effect does. It adds a nice little wobble to the camera. And then over here, amplitude and frequency, so we can play around these. So you can make it really intense, so something like this, that is way too intense. So there you go, quite a lot. So for something more subtle, maybe put 0.5 and 0.5. There you go, just a slight little movement in the camera. So this would help make the game a little bit more dynamic, so this could be a fun effect. Although actually, in my case, in order to make sure that the video doesn't get way too compressed, I'm actually going to disable this on my end. So just set the channel noise to none. But you can see how easy it is to add complex camera features when using CineMachine. And of course, when using CineMachine, if you want, you can use it to make your game a lot more unique. Now for me, I want the design here where the camera is fixed. But let's say, for example, you wanted the camera to actually follow the player. Like I said, go watch that dedicated video to learn all about CineMachine. But over here, very quickly, let me just show you how to do that. But at the same time, don't bother following this part. It's just to show what CineMachine can do that I'm going to revert back to this state. So first of all, for testing, one great thing about CineMachine is you can have multiple virtual cameras. You can have as many as you want. And then the priority and the game object enabled state is what defines which camera is actually being used. So for example, on this second one, let's make it follow the camera and put the priority on 20 so that it's above. Then over here for the body, I'm going to select transposer. Let's put it with world space. It requires a follow target, so let me drag the player as the follow target and put it slightly above and behind. Okay, so it's pretty similar as before. Then for the aim, let me also drag the aim player target. And just with this, it should already work. So if I head on play, yep, there you go. Look at that. The camera is now moving and following the player, so I can move the player anywhere. And yep, the camera follows along. So as you can see, it's this simple to really make some complex camera movement. Doing some complex camera logic just like this would require a ton of work manually, but with CineMachine, it is super easy. Then you can even play around with either priority or enable and disable. And there you go, CineMachine even transitions between the state of all your virtual cameras. So as you can see, lots and lots of things you can make with your camera very easily, all thanks to CineMachine. Like I said, in my case, I just want a fixed overhead camera, so I'm just going to delete this secondary virtual camera. And there you go, just this one on top, looking at the player, looking down with a low FOV. And yep, this is exactly the kind of camera that I want for my game. Okay, so that's CineMachine. It's a really awesome tool for making camera handling much easier. So this was a quick lecture all about learning about CineMachine. Now let's handle the task that was actually left undone quite a while ago. Let's finally learn how to refactor code and implement the new input system. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to refactor our code from the legacy input manager onto the new input system. So the simple character controller that we made is working perfectly fine with the legacy input manager. Like I said, this one is excellent for making quick prototypes and demos. As you can see, it's super easy to use. But now let's quickly refactor this code to use the new input system instead. Also, like I said in the beginning of this course, here I'm going to be focused primarily on building this game. So for example, for any Unity tools that I use, like the new input system, I'm going to cover enough to be able to use the tool and achieve our goals in building this game. But of course, every tool does a lot more than just what we're going to use. So definitely make sure to watch the dedicated videos linked in the description. For example, the input system tutorial is 40 minutes long, covering everything you need to know about system, whereas here we're just going to learn enough to know how to use it. So let's refactor this code to make it work with the new input system. Except before we work with the new input system, let's just refactor this code so we can completely decouple the input from the player class. Again, we want to focus on writing good, clean code, so we should keep all of our input logic in its own class that other scripts can access. Remember, the goal with clean code is to minimize and manage complexity. So every class should do one thing and just one thing, meaning that the player class should only handle the player, and then the input class should only handle the input. The only reason why I put this over here in the beginning is exactly to teach you about refactoring and how it's a very common thing that you should be doing all the time. This is exactly how I build my own games. I start by making a prototype and I write the input directly inside the player class, then at some point I refactor the code to split them up. So don't be afraid to refactor code, it's a perfectly natural part of the game dev process and actually a very good thing. Okay, so let's make a script just to manage our inputs. Let's make a new C# script, call this game input. Let's create an empty game object, give it the same name, input. As always, keep things clean, so put it on 000. Let's attach the script and open. Okay, so here's our script and let's get everything related to the inputs. On the player for the input, we are calculating the input vector, then getting the actual inputs from the keyboard and returning the input vector. So let's put this on the other script. So over here, let's make a new function. Let's make it public since we want to access it from the player. We're going to return a vector2 and let's call it getMovementVector. Now here, let's really just copy paste the exact same code that we have on the player. So let's copy paste all of this. Let's go and paste it here. Okay, so we get the input vector, we get the inputs, we normalize it, and then return the input vector. Okay, so that's it, super simple. Also, by the way, here we have an interesting question, which is, do we normalize the input over here, or do we do it over here on the player? Both options can be valid. You can make it so that the game input class returns a regular input, or you can make it return a normalized vector. You can use either option, but whatever you do, make sure you are explicit. So over here, I am going to normalize the input inside the game input class. However, I'm also going to make sure to rename this function. So instead of getMovementVector normalized. That way it is 100% clear. This returns the movement vector as a normalized vector. Okay, great. So now let's use this in our player. Over here in our player class, we need some reference to our input class. Now, later on in this course, I'm going to teach you about the singleton pattern. But for now, let's just do a simple direct reference. Again, remember, don't make it public, make it a serialized field private. So over here, let's make a serialized field private of type game input, and let's call it just game input. Okay, so we have this, we're going to drag it in the editor, then over here, we simply grab the vector2 for the input vector, we simply go into this one, and we get the movement vector normalized. And okay, that's it, no more errors. Let's just make sure to save all of our scripts. And back in the editor, let's go into the player and just drag the reference for the game input. Okay, so just like this, everything should still work. Everything should work exactly the same as previously. Let's test and make sure. So here we are moving, and yep, everything still works. I can move in any direction. Okay, so far so good. And what we have done here is essentially we have refactored our code and completely separated the input from the player class. This is an excellent thing, so again, don't be afraid to refactor code. Also, what we did here of putting the code in a separate class, and then doing a quick test to make sure that everything still works the same as previously, this is exactly what you should do whenever you do some kind of reorganizational refactoring. In the end, you want to end up with the exact same behavior as previously, just with the code organized in a different way. Okay, so now that we have this separate game input class, Now we can very easily refactor the legacy input manager onto the new input system. So the first thing we need is to install the package. So let's open up the package manager. Let's make sure up here we are in the Unity registry, make sure we are in all, and let's scroll down to find the input system. So here it is. Let's go ahead and install. Okay, the package is installed, and right away we see this message. Basically, it's asking us if we want to enable the new input system. Now, you could click on yes, but let's actually go ahead and click on no. We're going to enable it manually, so click on no. Then let's close this window. And now let's go up here into edit, then let's go into project settings. Then on the left side, let's go into player. And now let's scroll down, expand over here the other settings tab. And keep scrolling down until we see, yep, here it is, the active input handling. This is where you can select which input system you're using. Basically, if you click yes on that window, it would automatically set this option to use the new input system. So it would only enable that one and completely disable the legacy input manager. But like I said, the legacy input manager is still pretty useful. So normally for me, I prefer to enable both of them. So let's go ahead, click on both, and this will restart the editor. So okay, let's go. Alright, the editor has restarted, so now the new input system is now enabled. Okay, so the way that this system works is by creating something called an input actions asset. So on the project files, let's click on the plus icon, let's create something, and let's find the input actions. So we need to scroll down here, so click on the little arrow to go down and find the input actions. Creates this file, let's call this the player input actions. Okay, now let's go ahead and double click on it. And yep, there you go, out pops out the input system window. Basically, this one is where we're going to manage all of the settings for all of our inputs. Also, by the way, like I've mentioned, if you're watching this in the future and for some reason the input system got a new update and changed this window, if so, make sure you check the pinned comment. I'll keep it updated with any changes on anything in this course. So over here, we've got the action maps, then we've got the actions, and then we've got properties. Now, action maps are how you can have different maps. For example, one action map would be for the player whilst walking normally, and you could have another one whilst driving a vehicle. Then for the individual actions in each action map, and finally the properties for each action. Again, if you want to learn about the entire input system itself in more detail, go ahead and watch my dedicated video on it. In order for this course to not be 20 hours long, I'm really only going to use enough to make sure that we can achieve our goal. So over here, we just need one action map, so let's click on the plus icon. Let's name this the player. And now for the actions, right away we have a new action. So let's just rename this one. Let's call this action move. Then with this action selected, over here on the action properties, we can select the action type. Again, in the dedicated video, I cover what all of these mean. For movement, we do not want a button. We want movement in multiple directions, so let's go with value. Then over here for the control type, for this one, let's go with a vector2. And then let's expand our action. Over here, we can see our bindings. However, we don't want this default binding, so let's actually delete this one. Instead, let's click on the plus icon, and over here for the type, first for the keyboard, let's go with this one, up, down, left, right, composite. So this one adds essentially 4 bindings. Let's go ahead and name this WASD. Then for the up, let's select the binding. So over here on the path, let's click on it. Then we can either find it manually over here or click on the listen, and now press the W button. Yep, there you go, W. Then for down, let's go ahead and listen S. Then for the left, listen A. And for the right, let's listen D. Okay, great. So with this, our input asset is correctly set up. One thing you must never forget is up here, make sure to save the asset. You can see this little asterisk here. That means we have unsaved changes. Also, alternatively, there's an autosave there. But for now, let's just manually save the asset. Okay, great. So now let's see how to actually use this in our code. There are many ways we can use the input system. One way is by using the built-in player input component. So for example, on the player, we would add the player input. So you could add this one, attach an input actions asset. So this is our player input actions. Then over here, we have various behaviors in order to be able to trigger our actions. But in this course, like I said, I'm going to be using the exact same code quality that I used in my own Steam games. So I will not be using this component. So let's remove this. Instead, I will be using the native C# method. So let's select the player input actions. And over here on the inspector, we see this nice toggle to generate a C# class. Let's go ahead, enable it. And for these fields, we can leave them all on defaults. That's okay. Let's just go ahead, click on apply. And now it's going to generate those scripts and compile them. Okay, great. Basically what this is doing is auto-generating some C# code. And on the player input actions, we can see over here, yep, we've got the generated script. If you want, you can even open this to see all of the source code. Now all of this, like it says here, this was all auto-generated, so don't make any modifications